Next, let's learn about the elimination method for solving a system of equations. The elimination method is best used when neither variable has a known value. The goal of the elimination method is to manipulate one or both equations so that one variable will eliminate, leaving the other one to be solved. Let's try solving the system of equations below using the elimination method. Our example is 2x minus 3y is equal to negative 8 and 5x plus 3y is equal to 22. For our first step, we're going to check if either the x terms, 2x and 5x, or the y terms, negative 3y and positive 3y, will cancel out to 0 if we combine them as like terms. In this example, the y terms will cancel if combined. That means we can move on to step 2 and add the equations together. You may be asking, how are we allowed to do that? Well, it's true that our goal is to find the xy point that solves both equations. The x's and y's in the equations will be like terms. We also know that adding the same amount to both sides of an equation will not change the value. In this example, 5x plus 3y and 22 are considered the same amount. Because all of these statements are true, we are allowed to add the equations together, the x's with x's, y's with y's, and totals or constants with other totals or constants. In the end, one variable should eliminate or cancel out. 2x plus 5x is 7x, and negative 3y plus positive 3y cancels out, giving us 0. And then we have negative 8 plus 22 is 14. Now let's move on to step 3 and solve the resulting equation for the variable that remains. Divide both sides by 7 and you get x equals 2. Step 4 is to substitute your answer for this variable into either original equation to find the value of the unknown variable. Make sure to write your final answer as a coordinate point x, y. I'm going to use 5x plus 3y is equal to 22 and substitute in x equals 2 to get 5 times 2 plus 3y is equal to 22. 5 times 2 is 10. That means we have 10 plus 3y equals 22. And then we can subtract that 10 from both sides to get 3y is equal to 12. Now let's divide both sides by 3 to get y equals 4. Our solution is the point 2, 4. Finally, let's check the solution by plugging both x and y into either original equation. I'm going to use 2x minus 3y equals negative 8, which means 2 times 2 minus 3 times 4 is equal to negative 8, or 4 minus 12. 4 minus 12 is negative 8, and since negative 8 is equal to negative 8, our solution checks out. I'd like you to solve each of the following two systems of equations using the elimination method. Go ahead, pause the video, and try these two. For number 15, you should have gotten 0, 9, and for number 16, you should have gotten negative 4, negative 5. Now, let's try solving the system of equations below using the elimination method. X minus 5y equals 7 and x plus 3y equals negative 1. Notice how there are no variables that eliminate here. In a case like this, we first check to see if either variable term have coefficients that have common factors or multiples. In this example, the x terms are both 1. In order for them to eliminate or cancel, one term would have to be positive 1x and the other negative 1x. Next, we need to manipulate one or both equations by multiplying or dividing both sides of the equation by the same factor so that one set of variables will eliminate. In this example, you will need to multiply either equation by negative 1 so that one of the x terms changes to negative 1x. I will multiply the first equation, x minus 5y equals 7, by negative 1. The equation is now negative x plus 5y equals negative 7. I can now solve using the elimination method. Negative x and x cancel out. 5y plus 3y is 8y, and negative 7 plus negative 1 equals negative 8. Dividing both sides by 8 gives us y equals negative 1. Plugging this into the original equation, x plus 3y equals negative 1, we get x plus 3 times negative 1 equals negative 1, or x minus 3 equals negative 1, and adding 3 to both sides gives us x equals 2, so our solution is the point 2, negative 1. Let's look at example 3 and solve the system of equations below using the elimination method. Our system is 3x plus 10y equals negative 5 and negative 6x minus 15y equals 0. In this example, let's look at the x terms. 3 can easily be converted to 6 if it is multiplied by 2. That means we can multiply the entire top equation by 2 to get 6x plus 20y equals negative 10. Leave negative 6x minus 15y equals 0 alone. Add the two equations so 6x and negative 6x cancel out. 20y minus 15y is 5y. Negative 10 plus 0 is negative 10. We now have 5y equals negative 10, and we can divide both sides by 5 to get y equals negative 2. Plug this into our original equation, 3x plus 10y equals negative 5, and we have 3x plus 10 times negative 2 equals negative 5. This is 3x minus 20 equals negative 5. To get x by itself, we add 20 to both sides, leaving us with 3x equals 15, and we divide both sides by 3 to get x equals 5. Our solution is now the point 5, negative 2. Finally, let's solve the system of equations negative 4x minus 3y equals negative 6 and 3x plus 2y equals 2 using the elimination method. In this example, neither term is easily converted to the other, so we're going to choose to change both equations. The least common multiple of 3 and 2 is 6, so we're going to try and make a negative 6y and a positive 6y. Multiply the top equation by 2 to get negative 8x minus 6y equals negative 12, and multiply the bottom equation by 3 to get 9x plus 6y equals 6. Add these two equations together to get negative 8x plus 9x is x, negative 6y and 6y cancel out, and negative 12 plus 6 is negative 6. Since x equals negative 6, we can plug this into one of our original equations, 3x plus 2y equals 2, to get 3 times negative 6 plus 2y equals 2, or negative 18 plus 2y equals 2. It's now time to solve for y, so we can add 18 to both sides, giving us 2y equals 20, and divide both sides by 2 to get y equals 10, making our final solution the point negative 6, 10. Next, pause the video and try the 4 practice problems below. The figures below show how different students choose to manipulate the system of equations in order to eliminate one variable. Circle any correct choices. There may be more than one per system. For number 17, students A and B were correct. For number 18, students B and C were correct. On number 19, student A was correct. And on number 20, students B and C were correct. Now, pause the video and try the last 6 practice problems below. Solve each system of equations using the elimination method and make sure you show your work. Number 21, the solution was 8, 3. Number 22 had the solution 8, negative 7. Number 23 has the solution negative 2, 10. 24's solution is 15, negative 20. Negative 25 is 5, 5. And negative 26 is 1, negative 6. Make sure you are able to solve all practice problems and ask your teacher for help if you need it.